not there. 21. Oh. These are hard for me to see. These are hard. These are hard. Okay, well, let's look. If we let, first of all, if we let u be x over 3, that means, and I'm going to make it 1/3 x. That means du is what? 1/3 dx. How can we make the u show up? Okay. I say that, but I think what we're going to have to do is factor out a 3 or a 9. If I factor a 3 out of here, stay with me. If I factor a 3 out of here, I get 3 times 1/3 x squared plus 3. That doesn't do me any good. What if I factor out a 9? My thought whenever I saw this was, I know this is one of those wonky inverse trig functions, right, on your derivative sheet. And the one I was thinking looked like that, and I couldn't quite remember, but it's inverse tan, right? Isn't that right? So if I can make it look like this, then I'm okay. Do you agree? And the only way to do that, I know this last number has to be 1, right? And the only way to get that 1 is if I factor out a 9. So if I were to factor out a 9, I end up with 1/9 x squared plus 1. Does everybody see that? You're not used to factoring something out whenever it's not a GCF because it's a 1 here, but I needed this to be a 1. So to do that, I just divided, because if I distribute back through, I'm back where I started, right? I just essentially wrote it a different way. Well, what is this squared? Right? Which is what I have. This is 9 times x squared over 9 plus 1. Do you agree? So let's write it that way. Let's write it. Let's change this up, and let's say this is the integral dx over 9 times 1/9 x squared plus 1. And u is, so you could leave it written here, or you could take it out front since it's like a constant, because I could say this is 1/9 times all of this. So yes, but I just took it out. But here what happens is, because u is x over 3, this is 1/9 integral of u squared plus 1. It's not du yet, though, because I need it to have that 1/3, right? I need another 1/3 here, which means I need a 3 out here to counter it. Does that make sense? Bless you. All right, so remember, my du has to be 1/3 dx. I've got u squared plus 1, but I needed the 1/3 dx in there. So all I needed was the 1/3, and so to counter that, I put the 3 outside. Say that again. Yes, so it cancels, yes. And so that this now becomes du. So now I have 1/3, and u squared plus 1 du is inverse tan, right? 1/3 inverse tan of u plus c. Now I can plug that u back in. That one was tough. Yeah. So these are easier if they give you the u, right? I mean, if they didn't give you the u, that's terrible. Terrible. What else on your homework? 25. All right, I got dx over 1 minus x squared. What do you think? I think I would let u be 1 minus x. If u is 1 minus x, what is du? Negative dx, or negative 1 dx, right? So I need a negative here. I'll put a negative here to counter it. And so I end up with negative the integral of 1 over u squared. I can use that exponent property, right, for antiderivative and just add 1 to it. And I end up with negative. All right, so this is really negative 2, right? Negative 2 plus 1 is negative 1. So negative 1 u to the negative 1. Lots of negatives here, but these two cancel. So I end up with 1 over u plus c. And what was u originally? 1 minus x. Does that make sense? And then 23. The integral 1 minus cosine t over 2 squared sine t over 2 dt, and they said they said u was 1 minus cosine t over 2. So what's du? It's derivative of 1 minus cosine t over 2. Sine t over 2 times 1/2. That's exactly right. Don't forget to chain it. I have this. What I'm lacking is the 1/2, but I can easily give it the 1/2, right? I can give it a 1/2, but I need to counter that outside with a 2. So now I have 2 times the integral of u squared du. Antiderivative of u squared would be what? 1/3. And now you just plug back in what your u was to start with. Combine the 2 and the 1/3. So 2/3, what was it? 1 minus cosine t over 2 to the 3rd. That one looked a lot worse than it was. Anything else? I know. I do believe I'm going to grab mine. Bless you. Well, this is not even a use substitution. You see why? I'm going to take the 3 out. This is really just cosecant squared x, right? Which is what? More u sub. I'm going back and forth. I'm kind of trying to read y'all to see how you feel about this so far. If we're going to do definite integrals with u sub, or if we're going to just practice with this today. So y'all give me some feedback as we go. I'll let you. Were they hard? Which ones are you talking about? Like where there were bounds on it? Oh, with the trig identities? Oh, those are hard. Those are tough. I think review more today before we do the. I have a sheet. Apparently, I had to do that last year because I have a sheet for the second day of the sub. Let's see how it goes. All right, so what about here? This is straight off your green sheet. What's the integral? What's the antiderivative of cosecant squared? Negative cotangent. So -3 cotangent x. Oops. Don't forget your plus c. How about this one? That was it. That was easy, right? There was no u sub on that one. If you recognize that it was secant squared or cosecant squared anyway, then it wasn't. I'll give you a second to look at it and see what you think. Could it be u sub? Maybe it's not. See what you think. You'll probably want to reference this when you bring it out, unless you've already memorized everything. You have it all memorized? Mhm. Right. I would use u sub here because one's a derivative of the other, and you know that, right? As you look at it, maybe you don't remember exactly what it is, but you know one's a derivative of it. Do you have 2 different drinks in those cups? One's what? Do you have a second block too? Oh, okay. I got you. I mean, it's okay. I just want. That's why she was late. Yuri is just throwing you under the bus this morning. He said you just had a rough morning getting it together. A little late getting up and whatnot. I was gonna say, what did you get for like the most loyal customer of all time? Make me U. Cotangent. Why cotangent? Because the derivative, that's right. So if I let U be cotangent x, the derivative of cotangent x is negative cosecant squared x dx, and that's already in there. The only thing I need to give it is what? A negative. So now I have negative the integral of the square root of u du. Well, that's an easy antiderivative, right? I hope. So this is u to the 1/2. So add 1 to it. 2/3 u, 3/2. Don't forget the plus c. So negative 2/3 cotangent x to the 3/2. Let's see. Did you? Oh, look at there. So this is much too easy for y'all. Mark, set, go.
These are the ones I'm not good at.
I don't know. You can.
Oh, wait.
Huh? So, is this one on there?
Well, it's long.
I guess you don't then. So you could. That's if this is a constant and not a variable. You see what I'm saying? Well, you fixing to stare a hole through that paper. What do y'all think? Me too. I just look at this. Okay, if I split them up, I got 1 over x times 1 over log x dx. So what are you let that y'all? That's exactly what I would do. I would let u be log x, which means du is 1 over x dx, which is in there, right? So this just means I'm doing the integral of 1 over u du. Oh my goodness. What's the antiderivative of 1 over u? Natural log. All right, so I got natural log of u plus c.
What?
Yeah, that's what they got too. So it's the natural log of x plus c. Isn't that crazy? All this fun in calculus, I tell you what. Go ahead, Jen. Yes, because you're talking about these two? Yes, because those two together make the du. See if you can do this one that's like the one we did in the homework. These are fun once you start getting the hang of them. 42. Hmm. Well, that's where I'm thinking I'm going with this one. So let's see. Let's talk through it then. I noticed the squared at the bottom, and as I look through, that's got to be it. This has got to be trying to get us to an inverse tangent. So how can I make the bottom look like x squared plus 1? The only way I see to do that is what we did before, where we take out whatever this is, right? So 25 times, that would leave me 1 over 25 x squared plus 1. I need this to be my u squared. So what would I need u to be? If u squared is 1 over 25 x squared, 1/5 x. So if I let u be 1/5 x, and du would be 1 over 5 dx. And let's just keep everything the way it is and plug in so we really see what's going on. Okay. What do I have? I have a u squared. And I think I'm going to ignore all this right now. In fact, what I might even do is go just to kind of help me see what's going on. You don't have now. I realize I'm going around my thumb here, but I'm trying to take you through my thought process here. So now if I let u be 1/5 x squared and du is 1/5, that means I'm missing a 1/5 here, right? I need a 1/5, which means I need to counter it out here with a 5. Now I'm set up. Eight on the outside. 1 over u squared plus 1 du. This was a good one. Caroline, I love watching your facial expression. So if I let u be 1/5 x, right? What a right. This inverse tan, and it's downhill from here, right? I just plug back in that 1/5 x. 4x over 5. Your turn. I know. It's terrible, isn't it? I'm almost done. Yeah, it's supposed to be. Sorry. It's supposed to be that. Yeah. Let your green sheet guide you. That's fine. Just make sure if you do it that you do that. What do you think? You sub. I really don't want to get into bounds today because when we get into bounds, we also have to adjust the bounds for our U substitution. So I think we'll practice. I'll let you practice with this some independently.